Okay, I've got 12 noon. So welcome everyone. Jeff Jensen, Director of Community Programs with Trees Forever here. We have got a fantastic speaker on a topic that's near and dear to my heart. If this is your first time to a Stewards of the Beautiful Land webinar, welcome. I encourage you to check out some of our additional webinars on the Stewards of the Beautiful Land landing page on the Trees Forever website. That has all sorts of great information about upcoming webinars, as well as some of the in-person field days at various counties throughout the state that we'll be hosting here in July, August, and September. Reminder to save the date for some upcoming webinars that we have. Again, these can also be found on that Stewards of the Beautiful Land landing page on the Trees Forever website. A reminder about our Facebook page. We have a Stewards of the Beautiful Land Facebook group. Bree's doing a great job of answering questions there and posting things. So if you have items that you would like to post, we encourage you to do that. This is also a way to stay informed. And some upcoming webinars. We're going to be here in 2 weeks talking about water quality in invertebrates, again with Jackie Gautsch. So that's going to be another fun opportunity. And then we're going to be looking at natives for butterflies. And so that's going to be an interesting presentation with Nate Brockman. Today's agenda is going to be a talk by Jackie Gautsch on water quality monitoring. Some upcoming field days to be aware of. Coming up pretty quick here, we have a tree ID care and maintenance workshop with Pat Moore in Crapo Park. That's going to be in Burlington. And then on Saturday, we have our very own Bree, and she's going to be leading a prairie walk and history lesson at the Darrell Smith Prairie on the campus of UNI. Then on Tuesday, July 16th, come on over to Story County. We're going to be at Doolittle Prairie with Dr. Tom Rosberg. It's going to be a fantastic opportunity to see this remnant prairie in Story County. And then before you know it, it's going to be here August 1st, and that's going to be a roadside planting tour and establishment discussion meeting at Wapsie Pines Nursery near Janesville in Black Hawk County. Again, all of this information and details can be found on the Trees Forever website on our events calendar. So I encourage you to check that out. And so next up, I'd like to maybe set the stage a little bit for today's topic and our featured speaker. So it's well documented how native perennials provide a multitude of benefits, from wildlife habitat to aesthetics and beauty to improved water quality. However, it's sometimes not obvious to most folks how these native perennials provide or improve water quality. And that's where our speaker today is going to fill us in, as you might say. Jackie Gautsch is a monitoring coordinator with the Iowa DNR, and she's going to enlighten us and give us kind of a sneak peek behind the scenes at what water quality means and then how we monitor it in Iowa. Just a note, Jackie wasn't able to be with us today. She's dealing with the aftermath of the historic flooding in Northwest Iowa, but she was kind enough to record this presentation for us so that we can share it with you all. But unfortunately, it means that she's not going to be able to answer questions at the end. However, fear not, she's instructed me to give you her contact information so that you can reach out to her directly if you have any questions about today's presentation. And then a reminder that she'll actually be with us in 2 weeks at our next webinar. Jackie, again, she'll be live with us talking about invertebrates and water quality. That's going to be a really fascinating presentation, and she'll answer any and all questions at that one. So without further ado, let's get on to our presentation.
Hi, my name's Jackie Gautsch. I'm with the Iowa Department of Natural Resources. I'm currently an environmental specialist senior with what's called the Water Monitoring and Assessment section. And I'm here today to talk to you guys about water quality monitoring here in Iowa. All right, so just a little bit about our program within the department. We are responsible for the design, implementation, and the management of all of the water monitoring programs within the department across the state. And the reason that we do this is to provide consistent and unbiased information about the conditions of the surface and groundwater we have here in Iowa. And so we want that decisions that are being made about those resources, the development, the management, and the protection of those resources can be of the best that they are. Okay, so I'm going to talk to you about a variety of programs that we have here in Iowa, why we have them, what we do with them, and then also I'm going to share with you how you could actually look at the data that we're collecting so that you can learn a little bit more about the water quality local to you. So we have a stream biological monitoring program, an ambient fish tissue monitoring program, a lake, a stream, and a wetland monitoring program. So we also have a groundwater monitoring program. I'm a little less involved with that one, so I won't talk about it today, but there is data available on our website that I'll show you later in this presentation that you can look up and see groundwater data for your area. Okay, so before we design a monitoring program, there are a variety of questions that we always ask ourselves. And anybody that's doing any type of scientific inquiry is probably going to be asking themselves the why, what, how, where, when, and who. Okay, so the why for us obviously is water quality. And so we want to look at what are the issues and what are the questions. And so for the department, in our section, the question is, what is the condition of the water in Iowa? We just want to know what's going on out there. Okay, so the goal is to learn about the Iowa's water, what's the quality, and then also to share that information. So we look at the what indicators, what parameters, but also where will we be going? What types of water bodies are we going to be testing for? And then the how, what kind of sampling are we going to be doing? The sample that we do with our ambient program are all approved methods with the EPA, Environmental Protection Agency, part of the federal government. What kind of laboratories are we able to use? We use only certified laboratories for our ambient monitoring programs. And then a big one for us is we collect a lot of information. So that's a lot of data. So what are we going to do with that data? And so how do we report that data? How do we manage it? How do we serve it out to the public? So we talked about the where, what locations, how many sites, when, how often. Are we only going to do this in the summertime? Are we going to be doing it year round? What size water bodies are we going to be doing? What types of water bodies? All of those things. And then the who, or the how are we going to get all this done, and assign those various tasks. And that's where a lot of partners come in with our monitoring. Okay, so I'm going to briefly just talk about the different programs that we have throughout the state. So ambient lake monitoring is a big one that we have, and it started in 2000 mostly. We do have some historical data that you'll be able to see on our database as well. But for the most part, the true ambient monitoring started in the year 2000, and it primarily focuses on our significantly public-owned lakes. So these are the lakes that are owned by a city, owned by a county, owned by the state, owned by the federal government, and other publicly owned lakes of interest for restoration. So some of these would include some of our shallow lakes or other lakes that maybe aren't as large as some of our significantly public-owned lakes, but they're some interested in doing some watershed work in that area. So each summer, we sample these lakes, 140 of them, 3 times throughout the summer, starting in May and go through September. A big partner with this project is going to be Iowa State University. We do contract them to provide staff, summer staff, to go out and do the actual lake monitoring, the collection of the data, and then also to process this data in their certified lab. So here we're looking at a picture of Iowa and showing the location of these said lakes that we monitor 3 times a year. So you can kind of look, we do have lakes spread out throughout the state. In northwest Iowa is going to be most of our natural lakes, including some of our natural shallow lakes. And then you'll notice that a lot of our other lakes are either oxbow lakes, so riverside lakes, or impoundments, or created reservoirs. Okay, so what kind of things do we test for? So again, we're looking at the why. Why are we monitoring these lakes? So one of the biggest pushes for an ambient monitoring network or a group of sites that you monitor on a regular basis is the Clean Water Act. So the Clean Water Act is a piece of federal legislation that was passed in the 70s, and it is passing on responsibility to the states and tribes to say, what water bodies do you have? What kind of uses do you guys use them from? And by you guys, I mean the people of the states and tribes, so Iowans. And what kind of things do those lakes need to represent in order to be used for those uses? So a designated use is just an official, we use this lake for swimming, primary recreation. We use this lake for drinking water supply. We use this lake for general habitat, so aquatic life. And then within each of those uses are what we call standards. And those are the basically standards, the level that we want to hold these water bodies to in order to meet those uses. So we monitor for a variety of things that help us understand whether or not those water bodies are meeting those designated uses or meeting the levels of the standards in order that we can use those water bodies for the uses. So that's just a fancy way at looking at all of the different ways that we can test the water to determine, is the water good or bad? Can we use it for drinking water? Is it safe to swim there? Are there fish able to reproduce and live in this environment? So temperature, pH, dissolved oxygen, turbidity are very common parameters that we monitor throughout a lot of different water bodies. For the lake specific, we look at depth, thermocline depth, and Secchi. And then also we do a variety of laboratory analysis looking at nitrogen, so ammonia nitrogen, nitrate, nitrite, nitrogen, TKN, and then some phosphate series. So orthophosphate, which is a dissolved form of phosphate, total phosphate, and then chlorophyll A and phycocyanin. Those are looking at whether or not we have certain algae types or what level of algae growth we have in those lakes. Total microsystems, so these are looking at some of the possible toxins that some of these algae might be releasing, and then phytoplankton and zooplankton populations. So by looking at this different data, we can look and see, are we meeting the designated use? Can you fish here? Can you swim here? Can we use it for drinking water and so forth? So if you're interested to find out about your lake in your area, sorry that this link is so long, and hopefully you guys can go to this link. And this is our ambient lake monitoring site that is in our what we call Aquia water quality database. So this is a database where we hold surface water, groundwater data, chemical data, physical data, and then also some of our fish tissue, which I'll talk about here in a little bit. So when you go to this site, it'll pull up a map and it shows all of the locations with a green dot. And then on the left-hand side will be a list of all the sites that we have data for. And then you can kind of get some little details showing all the data that's been monitored and the number of sites that we have. If you click on a particular site, it's going to take you to a page that looks like this. So the first thing you're going to see is a site map showing that location. So this is Big Creek, which is in Polk County, just kind of north of Des Moines by Polk City. And there's some site information. So it kind of Iowa or 21 Iowa is the Department of Natural Resources facility ID. What kind of water body is it? What county is it in? What state it is in? The latitude, longitude, in case you wanted to map it. When the first data was recorded, so 1973, you'll see that there's some historical data associated with this site. In addition to, you'll see we have 2023, which is our most recent year of ambient lake data. And then it'll show the total results. So there's a total of 2,938 data records associated with this location. If you look over on the left-hand side, you're going to see there are 4 buttons that have additional information available for them. So this is the site button. It's kind of the default one that it takes you to. If you click on the results button, it's going to give you a list of all of the data. Okay. And there's a few tools here that you can use if you want to look at the data specifically for your lake. Over here is a little download tab. So this is where you can click on this and it'll give you the option to save it as an Excel file or a whole bunch of other different options that you can then save to your computer, and you can do graphs, you can make maps with it, whatever you would like to do on your own desktop. However, we do have some tools that can be used that I'll show here in a minute where you can graph some of this information right on our website. The other thing you can do is categorize by project or task. So let's say that you just want ambient lake sites. So you can pick ambient lake SHL, and that will pull down all of the data that we've done through the ambient lake program at the SHL lab. There's other programs like ambient lake ISU. That's all of the ambient lake data that we've done at the ISU lab. And then there's some special, you'll see there's Bachman, which is some of the old historic data, that sort of thing. Another drop-down box that's very helpful is, let's say, you know what, I'm just interested in knowing about the dissolved oxygen levels at Big Creek because I like to go fishing there. And so I want to know, is Big Creek regularly above the standard of 5 milligrams per liter of dissolved oxygen, which is the standard for warm water for fishable lakes in Iowa. So then you can pick that parameter from this drop-down box and it'll organize that data. And then you can kind of quickly skim through and view that data. So that's kind of the data view. So we have two other buttons, Trends and Lake TDS. So the trend button is going to take you to a page that looks like this, and it is where you can graph data. So if you're interested in specific analyte like dissolved oxygen, you can pick that analyte from this drop-down box and pick the dates that you want, and then it will bring up some data like this. So I picked dissolved oxygen. This is a slider tool. So if I want just the ambient data, I can go from 2000 until current. But if I want to see that historic data, I can slide this slider over and see all of that data. Once I have my parameter and my date selected, I hit the Trend It button, and it's going to bring up a graph and a box plot. So this is just showing the distribution of the data from 2000 to 2003 at Big Creek for dissolved oxygen. And on here, kind of helpfully, it gives you an average or a trend line. And you can see my trend line is well above the 5, which would be down here. However, there are a few times that it bops below 5. Okay. So that's just a quick way that I can look at some of that data. I can scroll down even further and I can look at the yearly summary. Here's showing me milligrams per liter, the average, the max, and the minimum value. And then also, if I'm truly just interested in the dissolved oxygen data, I can download just it rather than the data from the earlier data view page. And I can get just the water quality data. Another kind of helpful thing that over here is it's organized by year, and it gives you the max and average and the minimum for those years. Then it also tells you how many samples were taken. So remember I said ambient lakes are monitored 3 times a year. So here I can see 2012 has 11 records. So that tells me that we were doing some specific monitoring for another project during that year. And that happens to be some TMDL monitoring that we've been doing on this lake. Okay, so that's the Trends button. For the lake monitoring program, we have something called Lake TSI. So this is a classification system that we use, or other programs or managers can use, to rate an individual lake based on the amount of biological productivity that's occurring in the lake. And there's a few different ways to calculate this. You can look at Secchi, you can look at chlorophyll A, and then you can look at both Secchi and chlorophyll A, or you can look at total phosphorus. And so this just kind of shows you those 3 different ways, and then the average looking at the different levels of TSI. So you can kind of just look and see, where does this lake rank? And you can do this for multiple lakes and kind of compare and contrast the different lake TSI levels. Okay, so what is TSI? So TSI is basically looking at trophic status. So this is, what is the biological productivity in this lake? Okay. And ideally, you think about, you know, the nice, clear, low nutrient lakes, you know, the very deep lakes. And so those have low productivity. So you'll see that there's not very high chlorophyll. The Secchi is very deep. You can see very deep into the water column, and it has pretty low phosphorus levels. In comparison, you have your hydroeutrophic lakes. So this is the lakes that you're going to go to and sometimes have that green scum. Secchi is non-existent or very, very shallow, and you have lots of phosphorus. So it's on a scale from 0 to 100, and that's kind of how you can rate the biological productivity of a lake system. Okay, so a few things that kind of branch off from our ambient lake program are our beach-owned, our state-owned beaches monitoring program. So these are beaches that are monitored at state-owned beaches, and we look at whether or not people should be recreating in that water or not. So we're looking at microcystin levels, so toxic algae, and then we're also looking at E. coli bacteria, which is an indicator bacteria that can help determine whether or not something is safe for swimming. So we're not actually looking for E. coli and the E. coli that makes you sick. We're looking at E. coli that is an indicator of any warm-blooded fecal matter that might be getting into the beach. And that might be an indication of other pathogens could potentially be there. The other program that we have, our shallow lake program. So some of our shallow lakes are included in our ambient lake, just depending on the public ownedness, I guess you would say, how much of that lake is publicly owned. But then we also do some other targeted monitoring activities in some of our natural shallow lakes, looking at the water quality after or before restoration activities have happened. So that's briefly our lake monitoring program. The next one I'm going to talk about is our stream monitoring program. So this roughly started in 1999 and is a network of stream stations throughout the state. Big partners with this program are going to be USGS. A lot of the sites that we have are where USGS maintains a flow monitoring station. And then also the state hygienic lab that runs a lot of our water quality samples and then also collects a lot of these samples. Currently, we have 60 stream sites that are sampled throughout the state, and each state is sampled monthly. Again, you're going to see kind of an array of parameters that we monitor for. Temperature, pH, dissolved oxygen, turbidity are kind of our standard on-site parameters that we monitor for. We also look at for some nutrients, so ammonia, nitrate nutrients, and TKN are our nitrate series, orthophosphate, total phosphate. We also look at chloride. Chloride can be a good tracker for human inputs. And then chlorophyll A, again, and then we also look at E. coli levels and then metals and then flow or how much volume of water is moving through that system. So much like the lake monitoring program, you can go to our ambient stream monitoring Aquia site. And here down here is the pathway for that site. Again, it has a map of the locations, and then it also has a list of all of the sites that we monitor on a regular basis. You can see from 2013, so it gives you the last 10 years, to 2023. We have 164,197 sampling results at 61 different site locations. If you click on any one of these site IDs, it's going to bring you to a page that, again, looks a lot like what we saw for the lakes. So this happens to be the Yellow River in Alameda County, and it gives you a map of that location, again, that site data. And then you're going to see there's some additional links here to some additional data that's out there. So if it has a USGS site, there's the link to that right there. And then the BioNet site, which is our biological data that I'll talk more about in my next webinar. And then 3 buttons here are the site location, which we're currently on, results, and the trends. So just like the lake, if you go to the results page, gives you a variety of drop-down boxes. You can look at by project. Again, you can look by analyte, which is probably the most helpful for me. And then you can just download all of the data for that site from all of the years of monitoring, and then do what you want with it on your own computer. Another one, again, is the trends button. Again, it looks just like the lake. It'll tell you what site you're looking at. You're going to pick what analyte you want to chart. So here I looked at temperature. And again, there's a scale, a time scale that you can pick. So I just picked 2000 to 2024, which is our ambient network. Hit that trend it button, and it's going to bring up this graph. So you can see that this stream, because it's monitored monthly, has a wide variety of temperature. And then it kind of gives you the trend line as well. It'll also give you yearly summaries. So you can look at what is the average, what is the minimum, what is the maximum water temperature that is available. data. And then it'll also bring you to this list of the summary that you can then download and use on your own computer. Okay, so I'm going to talk a little bit about the biological stream monitoring that we do. I'm going to talk more in depth about this at the next webinar, which I'm sure that Jeff and Karen will pop in a date in the comment section, hopefully. This program started in 1994, and it samples fish and benthic macroinvertebrates across the state in order to look at the biological integrity of Iowa streams and rivers. So a designated use that we have often for our streams is aquatic life. And so this is looking at that designated use of, it's important for us to have good quality aquatic life in streams. That is a designated use that Iowans value. And so they need to meet a certain standard, which are what kind of populations, the biological integrity of those streams. So if you go to that website, and I guess maybe I didn't put the link to this on the screen, but I can share that if somebody wants to write that down, and I will make sure that that gets shared with the group. But if you also Google Iowa DNR Bionet, B-I-O-N-E-T, you will find a link to this site. And so this is a map showing of all the different biological sites that we've monitored throughout the state from 1994 until present. And there is a legend over here that can give you a little bit more information about all of those different sites. You can use the plus-minus tool to zoom in and out into different locations on this map. And oh, here's how you get to that map site if you go to Bionet. Guess that's in the wrong order. That's okay. Another thing that you can do is you can search by the interactive lists or sampling dates or different project tags. You can also go to the summaries and statistics, and it'll give you information about different sites. So if you go to search sites, it's going to give you a drop down, a list where you can, again, download all of that data for use on your computer. This is just a list of the sites. Or you can go by ecoregion, and I'll talk more about what ecoregions are in my next webinar. If it's warm water or cold water, different things like that, what huck it is, if you happen to know what huck you have. And then also, if you know the stream name, you can just go to the stream name that you're interested in. Another thing that you can do is you can look at different types of fish data that's available. So if you click on that, it's just going to give you some summary statistics about all of the fish that we collect in Iowa. So you just want to know, what are the most common fish found in Iowa for the ambient program? And it'll bring you here to some fish that may or may not be familiar to you. And then what's the most common by number? So when you're looking at number of fish, what's the most common? And then also can give you links to different sites there. Okay, so let's say I want to know what a Johnny Darter is, because that's one of the most common fish found in Iowa. You can click on the name of that fish, and it's going to bring you to this page where you can get a bunch of different types of information about that fish. And then you can also get a distribution map showing all of the locations where that fish has been found in Iowa. And then you can also look at that by watershed if you would like. And you can download all of this data. Again, all of the data is public information, and it is available for people to use and analyze. So if anybody knows any grad students that are looking for projects, we have lots of them. Okay, so let's say that I wanted to search for a specific site. So on this first page, I can click in this search tab, and I can write the name of a stream that I'm interested in, like Yellow River or Walnut Creek. And then I can navigate to that site once it comes down in that list. So here again, I've picked Yellow River, and it's going to give me a bunch of different buttons this time, but a lot vary the same. So profile is a lot like the site page. It's going to tell me information about that water body. But then also it's going to tell me when it was sampled, and then there's a number here that's score. Okay, so you'll see it has a fish score and it has a bug score, and that's the actual standard that we're looking for. So in order to be in this ecoregion, it has to have a FIBI or a MIBI. So FIBI is the fish score and the MIBI is the benthic score, to meet those different standards. There are also other tabs over here you can look at information as well. But if I click on the fish, it's going to tell me, okay, so for this site, fish score is 54, which is warm water and is good. So this site is meeting its designated use just based on this one piece of data. But additional monitoring would need to be happening to do a full assessment. It'll also give me a list of all the different fish that were found there. And then it kind of gives me a little bit of some of the information about different metrics. So the number of native species, sucker species, which is looking at an important habitat or niche of species, sensitive species. So these are species that only live in certain areas and so forth. If you want to learn more about biotic indexes, I will talk more in depth about them at my next webinar. Okay, so that's looking briefly at our biological monitoring. Another thing that we're kind of looking at with biological organisms in the streams is the fish tissue monitoring. So since 1997, the DNR has had an annual statewide collection analysis of fish for toxic contaminants. And the contaminants that we're mostly looking at here are going to be pesticides and metals. So this is a program that fisheries and our section work together on in order to collect the data that we need to make these different types of analysis. So here is the link to the fish tissue information. This link will bring you to a page that looks like this. Again, has the site numbers. If you click on any one of these sites, it'll take you to that information. Has the different site names. Again, there are either search tabs or drop-down tabs. If you type it in the site, you can type in the name of the water body you're interested in. Let's say you're just interested in all the lakes. You can type just the lake here and it'll organize it by that type. Or if you're just interested in your specific county, you can put that here. Again, it has this download button over here that you can then download all of the site information for all of the different sample sites that we've collected fish tissue at. So I picked Big Creek again. And again, you see the similar buttons over here of results. And then this one has a fish tissue. So over here, I can look at all the different sampling dates that have happened. And then I can look over here and see what kind of analyte. So let's say I'm interested in mercury, which is a very common contaminant found in fish tissue. So I can organize it by that. And again, over here, there's a download tab that I can download all of the mercury data found in Big Creek, in fish tissue from Big Creek. Okay. So another ambient monitoring program that we've done is wetland monitoring. So this is a little bit of a younger program. It started in 2005. And this is a statewide program looking at the way to develop protocols to assess wetland types throughout Iowa. So previous to this, there was not a whole lot of data on wetlands in Iowa on a statewide basis. So we're focusing on potholes, riverine, and fen wetlands. We monitor 30 sites on a rotational basis, and then we add new wetland sites that we call random sites as necessary in the program. So basically every 3 years, one of these 30 sites, or each of these 30 sites is sampled. We sample them 3 times a summer. And the parameters that we're sampling for, again, are very similar. It's a little bit shorter of a list because there are some parameters that maybe do or don't make sense to look at in our wetlands. And so we're just trying to figure out what are good designated uses and what would be a good water quality standard for our wetland sites out there. This does not particularly have its own Aquia site like the streams, lakes, beach monitoring, fish tissue have. But you can get to this data pretty easily from our Aquia website. If you click here to search the parameters that you're interested in, you can then pick 21 Iowa. So that's the Department of Natural Resources data. Go to project task and then pick ambient wetland. And that's going to bring up all of the wetland ambient monitoring program data that we have available. You can leave it on available analytes, or you can pick from this drop down. Say you're only interested in looking at what is the orthophosphate on the ambient wetland sites throughout Iowa. We do have some early sediment data, so if you're interested in that, but a lot of times you're going to pick the only water, and here you can pick a range of dates. Click the get results, and here's going to bring you all of the wetland data that is part of the ambient monitoring program that's been collected. And I selected 2012 until present day because that's when we really started to focus on those 3 wetland types. Again, you can hit this download button, and it's going to bring you to a page where you can download all of this data. You can click on these different sites. It'll bring you to a different site location. Okay, so let's say that I just want to look at generally at a map to see sites in my area. So here you can look at our general site, and it has a legend here showing the different types. So rivers and streams are orange. You can see that we have a lot of river and stream sites throughout Iowa. Lakes are going to be those ambient lakes or shallow lakes. Wetlands are purple, and then we have a few other data types as well out there. So I can zoom into any wetland site that I'm interested in. Here I've picked Hartley Heritage Fen. So this is a fen owned by the Jasper County Conservation Board. And it is a really cool fen. If you've never visited it, I would recommend it. And here you can click on the site dot, and it'll bring up this little info button that has a link to the site data. So if I click on that link, it's going to bring me to a page that has site information for that. If I click on the trends button or the results button, I can do the same things that what I did earlier with the streams or the lake sites. So here I'm interested in ammonia because it's a nitrogen nutrient. And from 2005 until present, or the most recent data, hit that trend it button, and it's going to show me that data. And that is the brief overview of the different ambient monitoring programs that we have here in Iowa. And I hope you enjoyed the presentation, and I'll turn it back over to Jeff.
Jackie, question here. Can you make the connection for me between Iowa and the Gulf of Mexico and the hypoxic zone?
Yeah, absolutely. Okay, so obviously a lot of our livelihood in Iowa is agriculture. We also have some thriving urban areas throughout the state. And so anytime that we alter the landscape, whether it be to grow food or grow grain or produce livestock or to use the land use for a parking lot at a mall or a golf course or a city park or any of those things, we're altering that landscape. So we're changing the way that that land intercepts water and then delivers it to a water body, which then delivers it downstream, right? And so ultimately, Iowa, we are upstream of the Mississippi River watershed. Eventually, all of our water will flow into the Mississippi River, whether it's through the upper Mississippi River or the Missouri River watershed. And so we are upstream of the Gulf of Mexico. So we are contributing to all the things that form the hypoxic zone in the Gulf of Mexico. So the hypoxic zone is an area in the Gulf of Mexico that is pretty much devoid of oxygen. And I talked earlier about how important oxygen is for all of the things that live in the water that breathe that dissolved oxygen, right? So if there's no oxygen there for them to breathe, they die. Okay, so basically this is what they call the dead zone. This is where things are not able to live because there's no dissolved oxygen. And the cause of that is all of the places upstream of the Gulf of Mexico flushing things downstream. And those things are sediment and nutrients mostly. So when you get a lot of sediment and nutrients into the water body moving through that landscape, what happens is nutrients are kind of like candy for a lot of algae, and they just eat it up really, really fast. And so you'll have this abundant growth of algae, but then eventually they will use up a lot of those nutrient sources and they'll start to die. So you have this cycle of algae growing very quickly, using all the nutrients and then dying, and then growing and then dying and growing and then dying. Yep. And then as their bodies float to the bottom and break down, it uses up all that oxygen. And then you have nothing left for fish and shellfish and other important things in that ecosystem to live.
So it's the decomposition process of all of that biomass from that algae and those other things that is actually sucking the oxygen out of that water
Yes.
to allow any life to live.
Yeah. Often in water quality, not only will you see direct effects of pollutants, so you'll see pesticides come in and say they kill off a certain organism or plant, right? And then you'll see the after effects of that, right? So something depended on that plant for its food, or maybe it laid its eggs on it, or it used it to hide from predators. And so you'll see that that organism is then impacted. Well, that organism could have been a very important organism, like let's say it's a crayfish that needs a lot of plant material to eat. Well, now the crayfish cannot live in that stream site or that wetland site, and they are kind of an engineer a lot of ecosystems. And so they aren't doing that engineering process. And so they are now, their absence is now affecting the habitat for other organisms at that site. So it's not only the direct effect of whatever it is entering the system, it's the things that affects. That's why they call it an ecosystem and not an eco chain.
I have a question. So, how does like the climate change affect the levels of algae that could be present in some of those that you're monitoring?
Sure. So we aren't doing any specific studies to look at how is climate change affecting the algae growth that we're seeing at different sites that we are monitoring. However, we do know that weather, which is what climate is made out of, lots of different weather effects add up to climate, affect water quality. So things like dissolved oxygen are easily affected by water temperature. Water temperature is one of the things that is probably most easily affected by weather. So when it gets warmer out, the water warms up. Warm water can hold less dissolved oxygen, and dissolved oxygen is obviously important for all of those organisms that live in that water body to breathe if they do not breathe atmospheric oxygen. Temperature can also do other things in the water body column. It can make certain types of plant growth inhibited. So certain plants need cooler, just like your house plants. Some of them need certain conditions to live and thrive. So some of our native plants don't do as well in some of the warmer temperatures, but some of the more opportunistic algae and that sort of thing, they thrive in warmer temperatures. So they'll start growing, and then a lot of times they will outshade some of the other types of plant growth that might be in that water body. And so then they just start to kind of overtake. So you might get an algal bloom. In addition, another thing that happens a lot is we're looking at a lot of more extremes. So we have periods of time where we are not getting precipitation. So we are coming out of a drought right now, right? 3 years, pretty much throughout the entire state. And so when we're looking at how that affects water quality, and I'll talk about how water availability affects benthic invertebrates in my next webinar, but they affect all types of parameters. So if a stream is not receiving the precipitation that it historically has, it might start pulling from groundwater to have its base flow. So then you start seeing groundwater depletion, or you might see certain areas of that stream completely dry up, and therefore certain organisms cannot no longer live in those locations. It also leads to problems with, let's say that we have some regulated discharges happening in parts of that stream, okay? And now we don't have as much base flow, so now most of that stream flow is coming from that discharge. And so then it might put out the balance of what we are allowed to be able to discharge into that stream segment as well. So it can have lots of different effects. And then we look at the opposite extreme, we can start seeing a lot more water quality impacts due to increased water levels. So having a lot more contaminants come in, a 3-year drought, and things are sitting on the landscape, and suddenly we get a whole bunch of rain. That coming in can lead to a big flush of pollutants coming in from runoff throughout the landscape. And then having increased water levels can also affect a lot of those organisms living in the stream that maybe can't withstand that quick flashiness of suddenly a lot of water in them. So climate can have a very big effect on water quality, and it starts with one parameter, and then it affects a lot of different things throughout that whole system.
If you have questions directly for Jackie, please utilize her contact email there. She would be happy to answer any questions. A reminder, Jackie will be back with us in 2 weeks, and she'll be talking about invertebrates and water quality. I think we're going to wrap this one up here for today, but I'd like to thank you all for joining us, and we'll see you in 2 weeks with Jackie Gautsch. Thanks, everyone.